We are committed to building a network ecosystem that supports in-situ programmability, giving users the right to customize protocols, flow tables, and processing logic at runtime. As we all know, fixed-function switching chips require a long research, development, and production cycle, and cannot keep up with the changing of user needs. Compared to traditional programmable switches, runtime programmable switches can perform runtime updates of functions without interrupting the normal operation of other already existing functions. Statistically, a Tofino switch with 64 100 gigabit ports requires 50 millisecond downtime for updates, leading to 37 gigabytes of data loss at full speed, and it takes longer to re-download the flow table. There are many scenarios that need the feature of in-situ programmability. For example, network telemetry or measurement based on real-time network conditions cannot be foreseen at design time, so it is better to make them on demand at runtime. Many in-network computing functions are not always needed and are resource-consuming, so it is better to make them hot pluggable at runtime. The change of traffic pattern and network scale makes it necessary to enlarge or shrink a table's width or depth, provision new tables, or change a search key at runtime. For multi-tenant services, modifications for any tenant cannot affect other tenants, but now the service upgrading needs to stop all services. Device updates can be destructive to the states of stateful functions, example, congestion control and caching. This can be avoided by uninterrupted incremental updates. Specifically, we use distributed on-demand parser to implement protocol updating, template-based stage processor to implement processing logic customization at runtime, virtual pipeline to improve the flexibility of the original pipeline, and disaggregated memory pool to add, recycle, modify flow table. We have implemented software simulator and hardware prototype, and next we show the software simulator in terms of 3 use cases: MPLS tag processing, ECMP support, and multi-tenant function update. The first use case is, the base program supports level 2 and level 3 forwarding, and hosts in different subnets can communicate with each other via C1 to C2. And now we want to add MPLS forwarding to C1, C2, and C3 at runtime. The step is: firstly, download configurations and flow tables. Following above steps, all of the 7 switches are configured. Then we update the configurations of the second switch, A1. Then delete old flow tables and action. Note that operations work when the final submit button is clicked. Now the old configurations are deleted. And next we add new configurations. Update works and then download new flow tables. After updating A1, we update C with MPLS forwarding. The configurations of A2 are the same as those of A1. And configurations of C2 and C3 are the same as those of C1. Update done, then packets are forwarded according to MPLS, not IP anymore. The second use case is, the base program supports level 2 and level 3 forwarding, and H1, H2, H3 can access H4 and H5 only via the top path. And now we want to add ECMP function to switch A1, A2 and A3, to guide packets to other 2 middle switches. The step is: firstly, download old configurations and flow tables. Obviously, the top switch 5 takes all the load. Then we add ECMP function to A1, A2 and A3 for load balancing. In this case, we don't need to delete any flow tables and actions. Just add the stage that supports ECMP behind node 6, and add related flow tables and actions. Download new flow tables to the new configured switches. Then the other two switches can balance the load from the top switch. The third use case is, the base program supports add and logic and aggregation. H1 emits packets with add requirement and H2 with logic and requirement. Now tenant H3 joins in the network with logic or requirement. The three switches need to support the new requirement. The step is: download configurations and flow tables, including two types of functions, logic and add, for original tenants. Then update the configuration for function logic or. For all the switches, push a new stage back for logic or function. Add a new stage, node 12, which contains logic or and drop actions. New function, logic or, is loaded.